Welcome to this buildingSMART room session as part of the buildingSMART International Standards Summit Rome 2023. Thank you for joining. My name is Sheila Kurailam and I will be your moderator today. Today's session is titled A Presentation of the Intermediate Results of the Applying IFC 4.3 Rail Project. This session is scheduled to last 90 minutes with time for some questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For the online attendees, your microphone will remain muted for the duration of this session. If you wish to ask any questions, please use the chat box in the control panel. For those in the room, please try to keep the background noise to a minimum and raise your hand if you wish to make a comment or ask a question. I would also like to bring to your attention that buildingSMART is committed to ensuring that the participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct, which isn't popping up on the screen just now. Keep going, there we are. And on that note, I'm going to hand over to Dieter to introduce our speakers for today.
Yeah, good morning, everybody. It's my pleasure to introduce my colleagues. I'm the project leader for this project, or project manager, but it's my strong conviction that those people who do the job and who create the success that we have should also have the opportunity and be on stage and talk about their work. Therefore, we have quite a lot of speakers today. So next to me sitting is Etienne, who is the leader for work package 3. Then we have Ji Zhang with us. I think you all know him. Yeah. Then we also have Anna Maria Dallot, who is responsible for business case 2, and Joao, who is doing business case 3. You will hear that in a minute. And Andreas Pinsenöller, who is responsible for work package 4, as well as Stefan Jaud and Sylvain Marie. Well, having said that, you'll hear the people shortly. I introduce the speakers to you. I'll restrict myself to a short introduction to help you to understand the background of the project. And there is quite a tradition with this project. It all started at a summit. Well, not exactly this one, but there is a good tradition of summits. And as we heard yesterday, there is also a good tradition of infrastructure in our host city. So I thought, well, more seriously, the project is the third project in a row, and it all started basically with the kickoff of the first project, 2018 March, in the summit in Paris. But there was also this was also the starting point for the first project. But there was also a time before this, and you can trace this back to basically 2015. Singapore, when we dealt with thinking about IFC for rail. The thing is that railway organizations felt, and thank you for SBB, where we stole this with pride, this slide, they felt that they have a need to harmonize their processes, and they have a need for a standardized interaction between their different processes, and this was how it all began. So the project actually is, as I said, the third one in a row. It started 2018 until 2020, where we dealt with the requirements on the side of the stakeholders, mainly with domain experts, and yeah, this ended then in the deliverables. If you are more interested in here, then you can see, then you can go to the links with the project report in March 2020. And then we said, okay, the next step is basically to develop the candidate standard for IFC 4.3, and actually that's what we did until March 2022. And yes, it's delivered. You heard yesterday the candidate standard is now in the ballot phase of ISO, and it will be, we expect this to hear by mid-May. And now, what is a standard for if it's not supported and come to life? So then we decided, or the stakeholders decided, to have a third phase here, where we support the implementation. And it's important for me to say that's all along the phases and the workflow of buildingSMART. So I hope this helps you to frame the project a little bit. And now I would like to hand over to Etienne to tell you more about the project and the results as promised. Thank you.
Thank you, Dieter. Yeah, about this project, which is called Applying IFC for Rail, I would like to first perhaps remind you what are the key challenges we are facing in our railway industry when we are talking about IFC. Here the question, I hope that you see the slide in total. That's not my case, but the challenges we have is that we have building, but we have also assets along we have linear assets that are placed all along the tracks. We have also a very large imbrication of various disciplines, from the electrical, electromechanical equipment, signaling equipment, which is also something about low voltage, but also mechanical. So we have many concerns that are today not available, not yet available fully on the software that we use for the design. And this is the main challenge, and this is why we decided to face this challenge with a program which is very aiming to implement concretely the use cases we have on our side. I just want to add also the fact that our systems are sometimes at the equipment scale. We are talking about a turnout or something very detailed on our track, but also at the territory, at the urban scale. So those different scales are also a challenge that we have to tackle. That's for the challenges, and let's say the solution we find is to gather the competencies that we can find on our side as the stakeholders. So we have stakeholders from different countries, as you can see in the slide, that went together in order to define the technical requirements, the consensus that we can find together in order to apply this IFC. In the meantime, we need to have, for this proper implementation, we need to have technical services, people that knows well how the IFC is working, and also, and it has been recalled this morning during the introduction for the game that we'll have this afternoon, we need the software vendors. So this project is made to make this overlap between those three groups of people: software vendors, stakeholders, and technical services. The goal of this project is definitely to bring requirements from rail appointing party, meaning that we need to be able to express what we have in mind when we ask for an IFC, what is the model of data that we want to exchange. It's also to define a method that will convey the requirements, the technical requirements we have on the railway side into the IT, the software vendor side. And that's this process, this methodology is where we worked a lot in this IFC, this Applying IFC for Rail project. Another thing very important on the aims of our project is to have this process reusable, not just for these three business cases that my colleagues will present you today, but to have something that is robust enough to be implemented in a long series of use cases we will have in the future. And for sure, at one point, we need also to be able to validate the output of this implementation made by the software vendor, and to be able to acknowledge the result of it. So here again, it's a question of methodology. So talking about methodology, we have put in place this process, and we run it through the 3 business cases we have. As you can see, we are playing with the 3 groups of people: the business stakeholders, the technical services, and the software vendors. The blue part is how we define the technical content of what we want to implement. Then the orange box is about how we create the test and the rules. Then it goes to the software vendor that is implementing what we request, and it goes back to the business stakeholders that is validating the result of it. Easy to say that now we'll see how it goes with our 3 business cases. And talking about the business cases, in Düsseldorf, it was in 2018. I was not there, so 19, sorry. The railway room defined 38 standalone processes in a big map that you have an extract of it in the slides. And based on that, we all together in the frame of this project, we selected 3 of them based on the 3 criteria that we can see on the screen. The first one is having something that is a process that is robust, replicable, and scalable, meaning that what we wanted to have is something that will show the value of the process. So we have picked up 3 business cases for this purpose. So these business cases will be developed with the co-leader of the business cases. Just to let you know, the first one is how we combine disciplines model all together, the model federation with IFC. Second one is how we place, how we locate equipment along the track, and that will be the purpose of the game of this afternoon. And the last is about the cabling for railway infrastructure. So just to focus on the team that is large today in front of you, but more in the background. So we have so it's one team made of technical services, people with a deep knowledge in IFC schema and data modeling, but also people from the technical part, let's say the railway part, that work together with the software vendor. And 2 last slides before giving the speech to the co-leaders. What we did during the technical part, the definition of the requirements at the beginning, we draw a process. We use a methodology to deliver user story and use case diagram in a way where the software vendor can understand and the technical services can understand this very sometimes confusing language we have in the railway. So it was the target was to find a consensus and find a language that is understandable by the people that are very well fluent, let's say, in IFC. So for that, we use those requirements formalization and a series of outputs that are listed in the screen have been used in order to standardize the methodology and to test our overall process. So that's where we are. Today it's a view through the 3 business cases that we can see in column and the work packages. We will go with the first business cases we'll develop with SHE is the IFC Model Federation. Just in a couple of, yeah, it's for you.
Okay, thank you, Etienne. Okay, I'm Chi Zhang. I'm from SBB, and I'm going to introduce the business case 1, BC001, IFC Model Federation. Okay, so IFC Model Federation, what problems that we want to solve? Railway is a very comprehensive domain that has many subdomains, or to say subsystems. So the problem that we want to solve, well, at least we want to address, is that how to federate several IFC 4.3 models in a consolidated model, which is, and what is the criteria to federate them, and what can be expected from this federation. And to do this business case, the objectives are, firstly, define a general process and the criteria for a model federation across multiple domains. And yeah, we would like to perform a series of test plans to validate the implementation. Okay. Well, not sure whether we can see this clearly, but anyway, this is the process map. This is the starting point of this business case, that we start to define this business case from a process map. Well, this IFC Model Federation is kind of quite generic business case, right? It's not specific to any domain. So we are trying to define a generic process and requirements that should apply to all domains. So it's not, all the requirements are not domain specific. They should apply to all the domains that in the railway. So from the beginning, we would have this project manager to define the AEL requirements, that's EIR requirements. And then this BIM coordinator define this project setup, the map coordinate system that should be used in the project breakdown structure. And then we go to the alignment. We make alignment as a very specific domain because it's very crucial in the railway. All the other domains kind of dependent on alignment. We need to position things along alignment. We need to make the linear referencing. And then after alignment is created, then we have at least 2 domains, and we could work in parallel or work step by step, and these domains will create their own elements and place their elements along alignment. Then we would like to federate these models to have an integrated model, and then can do some further work, for example, like clash detection. This is just a little bit background about the breakdown and traceability of requirements. This is the method that we applied in this business case, and it's not only for this business case. All the 3 business cases use the same methodology. This is the way that we try to break down the requirements, also to make sure the traceability of requirements. So starting from this BPMN process map that you saw in the previous slides, we make this use case diagrams based on each activity, and then also based on this use case diagram, and create this SysMail either requirement diagram or block diagram. Depends on what kind of requirements we're trying to define. It's to define the requirements for the data that should be exchanged, or the requirements for the software feature that we would like to see or would like to use in this business case. Okay, well, there are a lot of requirements in this business case because it's actually quite a comprehensive business case, but there are some core requirements, or say we really try to focus on these requirements. We want to see some concrete results that can fulfill these requirements. The first is this map coordinate system. So this is something that, map coordinate system, that actually georeferencing concept was introduced in IFC starting from IFC 4. But then, we have the infrastructure then join the IFC community, and then really this concept become more and more important. As IFC originally was based on this local Cartesian coordinate system, and now we really a project go into large scale in the infrastructure, so we want to see the map coordinate system features in the software. From all these tools and software. And and owner history and the version control, because we are doing the model federation, we need to control the versions. We need to say, okay, this element belongs to me, and this is editable by me, but, well, the other domain, please don't touch it. Or we need to do some version control thing. This is actually quite an old concept in IFC, starting from maybe 20 years ago, but we really want to challenge a bit for this, like, re-challenge a bit for this concept about owner history. And of course, the project structure. We need to have kind of agreements about the project structure in order to federate model. Otherwise, we don't know, which element belong to which part from the project. So this is a really a topic that has been discussed for probably already 4 or 5 years. But I think recently we have quite good results in the implementer forum. So we'd like to tackle this topic. And then, of course, the different ways of positioning. So we have this local placement, which is conventionally used in IFC, and then linear placement in infrastructure. And we also hope that we can have software vendors can support this positioning directly based on map coordinate system. Okay, so at the end we have for the requirements part we have this is just a summary of we have like 6 to 9 requirements for appointed party, and then required software features, and then this 56 IFC requirements. So these are the requirements that can be transformed as rules to automatically validate IFC models. And we have collected a data set and our test plan to do this business case. So this is the data set from SBB. It's like 18 kilometers railway line, and also based on this 18 kilometers railway line, we have a section which is specifically focused, and we have multiple domains involved in this section. So we have alignment, of course, and loading gauge, and building, and track, and drainage. Yes, and all the data sets are have the open format, so IFC, DXF, and LandXML format. Yes, and we have a test plan, so we want to do this business case step by step. So from project setup to the terrain, and then to alignment. Then we have like multiple domains should work in parallel, have models. So the loading gauge, the track, the drainage, and the building. So at the end, we need to federate this into one model. Yes, and the progress so far. So we have this the process map and the use case diagrams, also requirements. So basically, all the requirements part are finished, and we have the documentation of 2 test cases, and also a data sets are collected. Yes, also the requirements are extracted into an Excel sheet. So to be done is that we need to finalize all the documentation for the test case, and also would soon organize the meetings about the implementation with software vendors, and in April. Okay, then I think I'll hand to the Anna Maria to the business case 2.
Thank you. Good morning. I am Anna Maria Dalò, an RFI engineer, and I am co-leader of the business case sessioning on alignment with Dashwan Lee. In our use case, we have focused on understanding how IFC 4.3 can be used to define and retrieve stationing information on a railway alignment. Railway managers and stakeholders often refer to an element location through its mileage, which is related to the alignment. We need to be able to interrogate an element contained in an IFC railway model and retrieve its mileage information. The purpose is to provide a unified representation of railway alignment and establish the relationship between mileage and its corresponding position information, so that it becomes possible to obtain the location information of any mileage point or getting the mileage of any location on the line. Input, process, output. The input are business needs. Process are business case description via a process map. Then we have consulted railway experts to define user stories for each activity of the process map, define appointed party and software features requirements. And then we have collaborated with technical service experts to translate those requirements to IFC requirements. The output are appointed party requirements, required software features, and IFC requirements. Business case process map. We have started describing the business case via process map that put in evidence the main activities involved, the actors involved, and when the exchange information occurs. For each relevant activity of the process map, we have defined a user story and a use case diagram, specifying the steps performed by the user for carrying out that activity. For example, for the create alignment activity, the steps that the user will perform are draw an alignment based on the horizontal and vertical profiles and optionally count, use these types of curves for the horizontal profile, for example, clotoid, use these types of curves for the vertical profile, for example, constant gradient. These are the other stories and use case diagrams that we have defined. We have A2 place reference along the alignment, A5 place signal according to reference value, A8 interrogate signal. Based on the use case descriptions, we had several interactive workshops with railway experts on a Miro board. They have been carried out to define the appointed party requirements and the required software feature. Here you can see the main outcome, which are the appointed party requirements and the required software feature. The process was then taken over by the technical service who formalized the IFC requirements. So I have finished, and now Joao will introduce you business case 3.
Thank you, Ana Maria. So I'm João. I'm BIM manager from Aegis. I'm speaking here representing my colleagues Vincent Keller, Giovanni Guglielmi, and Dashuang Li, who are the co-leaders of this business case. So, cabling for railway linear infrastructures. This is a complex business case which involves many actors in the project life cycle. And the idea of this business case was to connect all those stakeholders and share information, collaborate and collaborate using the IFC files. So this business case, sorry, it starts in the beginning of the cabling design So in the definition of the cabling architecture, then it goes to the design of the cabling network, infrastructure network, sorry, and then at the end in the cabling laying activity. But what are the benefits of this business case? In fact, it will bring benefits for the whole project life cycle. It will bring it will make the activity more, in fact, it will be quickly to develop the design. We will be able to share information easily and federate IFC models to check the cabling occupancy and many technical requirements. But it also can be used during the operation, and because you can use those elements to manage and to track your operation planning. And of course, it will reduce cost and time during the whole cycle. So our process to develop this business case, it was very similar to the previous business cases. So in fact, we started defining the process, the process the BPMN with a BPMN definition, where we defined the process for these activities. And then, as it involves so many technical requirements, we decided to split our team in 3 different subgroups. So we had a subgroup specifically to treat the use case A, which was the definition of the cabling architecture. Then we have a subgroup to treat the cabling infrastructure definition, and in the end, another subgroup to treat the cabling laying activity. Each of these groups worked to define user stories and use case diagrams for those activities, and then for each activity in these use case diagrams, we tried to develop to extract some requirements. And then we have 3 categories of requirements: IFC requirements, software requirements, and appointed party requirements. At the end, we bring all those information together to run some kind of harmonizing in the requirements to create the final list of requirements for this business case. So during the development of this business case, we found some new challenges. Here is just a small list of some examples of what we found, what requirements we could extract from the business case experts. And mainly, we can identify that we have some issues with the software. Currently, the softwares that we have to work to develop cabling for railway infrastructures, they are not well adapted to our needs. So those requirements, I think that those requirements will help. In fact, will help the software vendors to understand what are our needs and what we have to develop. The good part is, in fact, cabling for railway infrastructure is also a mix of the cabling federation and the the model federation and the stationing. So many of the requirements, many of our requirements are already being addressed in the other 2 business cases. And with us, remains only some very technical requirements. So, for example, we have related to the software development, we have some needs concerning the cable routing and the cable laying that must be addressed, and also for the analysis of the cable occupancy along the cabling infrastructures. And the main need related to the IFC is now to understand and to analyze the railway as a system of systems. So I just would like to present you this image where we can see a manhole, and in this manhole in this example, it is part of more than just a single network, so more than a single system, and that's our main difficulty today to translate our project into the IFC elements. Thank you all. I'm finishing here, and now I'm letting the word to my friend Andreas.
So, good day, everybody. I'm Andreas Pinznöller, and I'm part of the technical services of the IFC Rail project, and especially responsible for the so-called work package 4, where we're dealing with testing in a very generic sense. And this testing is the main interface between the business analysis, what we have seen right before, and the communication with the software vendors. Therefore, we are using the buildingSMART software implementer forum on GitHub. GitHub is a very important, specific information technology term nowadays, which is coming from source control, but developed very, very extensively into the direction of collaboration, issue tracking, identifying problems, working on problems. And buildingSMART is using this platform, this technology, to support the communication with the software vendor community interested in IFC. And for us, it's the main deliverable platform for the IFC for Rail deliverables, which are test plans. And at the right, you see part of a screenshot where you have a couple of test plans, which are mostly rail related, plus a link if you want to look into it in more detail. You have seen this before. That's the test plan design for business case 1. The recommendation of buildingSMART. buildingSMART is operating this platform. The recommendation of buildingSMART was to make rather compact, rather small test plans to make it easier for the software vendors to engage with them. If it's one huge test plan, the access to all the content and all the requirement is much more difficult compared to smaller test plans. So one of the findings in our project so far is that we will work towards rather small and compact test plans. This model federation, you have seen this before. We are using a real-world data set. It's 18 kilometers long of alignment, and inside this alignment there is a station with many artifacts which are important to produce a station. Yeah. You have to talk about drainage, get the water away. You have to have a proper terrain model. You have to have the alignment, this core part for the railway system, and many other topics. This one is a screenshot of the first published test plan. Published means that it's now published on the buildingSMART GitHub for the implementer forum. And this is based on our business case 2, where we have an alignment together with 2 signals which need to be stationed along it. That doesn't seem so exciting, but believe me, there are many interesting details on all this. I think software vendors are on my side here. Findings. one of the findings I already mentioned before, make small test plans. Another finding is that communication is key. Misunderstandings are expensive. Each misunderstanding avoided is a step forward to the proper implementation of open standards, IFC 4.3. And you see here on the right side a small model of participating parties, and in the lower two you have the software world, the software implementers, the IT experts in the companies, the test managers, the testers themselves, and at the top you have the IT experts, the business IT architects, the strategists, the IT part. But much more important is that you have there a lot of rail engineers or other engineers. And what we learned is that those groups are not easily communicating. And maybe I ask my friend Joao and my friend Stefan to tell us a little bit about the discussions during the cabling business case 3.
Well, yes. I think that the main problem is semantic. There are terms, there are words that we use in the railway world, we can say, that have a completely different meaning in the IT world. So that's why sometimes it's difficult to us to communicate. And I think that it's our job also to try to find this way to create this bridge between those two words to I don't know, to find a solution for this gap.
Very well said. Yes, I think the most important point on this slide is that communication is key, and even though we all speak the same language, usually we communicate in English in our meetings, it's just a different background that we come from and different assumptions that one meets. So it was quite a journey to get, for example, the business case 3 to where it is today. So I'm very happy that we stepped over that problem, not necessarily problem. It was a fun challenge.
Yes.
To put it this way. So.
Well, I would say it's comparable to crossing the Atlantic for the first time, but it was done. Okay, I would like to ask you to continue, Stefan. I do the slides.
Thank you, Andreas. Yes, so we're now slowly starting work package 4, and we have been active also during the work package 3 in order to prepare the groundworks for work package 4. And what we have, of course, identified that there's a strong incentive to reuse from the different business cases, because the requirements that stem from them, yes, they are different, but at a certain core, they all require something similar. So we've focused on trying to reuse as much as we can, of course, to also not double the work and to reduce our workload. And so, for example, the iteration for the stationing on alignment, so the business case number 2, it produced 19 IFC requirements altogether. It was one of the first to reach this step. And for the model federation, the business case 01 that is now following suit, this one produced 56 of the requirements, where we have reused multiple of the business case number 2 requirements. So I think the statistic, yeah, it says 33%, so 1/3 have already been reused, and we didn't have to reinvent the wheel. Next slide, please.
Yeah, just one additional remark, excuse me. The plan, of course, is that for future business cases, this percentage will rise. At some point when Etienne and his people will do business case number 31, maybe it's 90%. That's the hope.
And if we, for example, look at this sketch that you've seen on the previous slides, on the left of the leftmost side, there's the project setup test plan, where we basically just deal with georeferencing the file and placing the whole model on the correct place. And we of course will reuse most of the things in the, let's say, alignment 01 example that then places an alignment within that model. So these 19 IFC requirements that could be reused are already within these two boxes, and you can see there are plenty of boxes also coming on our work plan, on our work schedule, and I believe this will, of course, enable us to reuse most of the things that we have so gracefully discussed before. Right, Joel?
Okay, thank you very much, Stefan.
Thank you.
Is it okay if I do the slides for you, Silva? The next slides are coming to be presented by Silvan.
Yes, you could skip this one.
Okay.
I'm not sure the final version, but
Oh, something happened here that used to be different.
it's, I guess my slides are after those.
They are different on his machine.
Yeah.
Okay, we have some technical issue here. His slides, who have been perfect, didn't make it into the presentation, but maybe you can give us a
Right.
short.
So let's focus on this one.
Yeah.
The whole idea of this slide is to think of what is a test. What do we have as in our tool set to do those tests? What do we test? Basically, we are here to make translations from business needs to engineering needs to IT needs and back to the engineering and back to business needs. And for that, we're testing several things. First, we're testing the proper use of the spelling used in the IFC files, where we are using the express schema validation rules. We can also test the grammar which is used for the IFC, so that's also down to the IT level. If we go up one level, we are testing the proper domain, and this is where the use case defined as for which you have small explanations before. They are really translated into domain-specific requirements that we test. And for that, we have mainly three tool sets. The first one is what we call IDS. It's relatively new in buildingSMART. Long conceptual history coming from MBD-XML, new implementation coming from scratch. IDS is an XML-based requirement list, all referring to the XSD, usual stuff. The other tool that we have in our hands is the duo between the Gherkin and the implementation of the Gherkin steps. This was interesting because it can mix plain language, usually in English, provided I have this configuration, I need this result when this happened. And I just read out loud some Gherkin definition file. And then to match this for the machine, to render this as a machine-readable test, we use usually Python. And buildingSMART has a strong experience with this using the IFC OpenShell library. And then we have the third tool in our belt, which is the human-in-the-loop debugging, the last layer in testing the equality in the geometry generations, because several software vendors use several geometry kernels, and we must make sure that the results of the geometry computations, of course, we're not only dealing with the facets, we are dealing with extrusions, solid geometry generations, and we need to make sure that the result is matching. And this is where the human is still in the loop, using friendly tools like the toolset from RDF, for example. So, all in all, without the slides and the few words, here is the different kind of tests and tools we have to make sure that the translation between the different domains really work.
Move on to work package 5 now. Thank you very much.
Before we do that, allow me a comment. I think from what you have heard the last around about 40 minutes, I think you can understand the challenges for project management to keep all these discussions within the framework of a given time and a given budget. And so I can charge quite a part of my gray hair to the project here. Evander is not with us today. He's busy in another presentation, so I'm handing over to Etienne, who has volunteered to step in.
Yep. So it's all about how we involve the software vendor in this story. So as soon as we have defined what we want in the business side and we have translated those requirements into something that can be understood by the machine, let's say, with the IFC and the software features, it's the time to hand over that to the software vendors. And again, the game that we'll do this afternoon will show us the end of the loop. So for that, we just for information, let's say we call for participation some month ago, and we had some candidates that some of them are in the room. It's not ended, and if you want to help Joao or Anna Maria or Chi implementing what they have defined, it's open to registration, so you can reach this page on our the project web page. You can also call Evandro, that I'm sure you know. The second slide that was planned to be shared with you is that for sure we have been supported, or this project have been supported by the Implementers Forum, the buildingSMART International Implementers Forum, that is gathering more than 20 vendors from more than 10 countries. And according to the statement you have on your screen, it seems that it worked very well when the requirements came to the table of the software vendor, and it seems that the answer we get for the first test cases have been very quick and I hope very efficient. I will end with the last step in the process, what we call the work package 6, which is the validation of when the implementation that have been done by the software vendor, when it goes back to the stakeholders, we are to the railway experts. So this we have not started yet this activity. What we would like, and it's very in echo to what Sylvain told us just before, it's a matter of anticipating how we'll validate the files when it will be issued by the software vendors. It can be IFC files for sure, that is a result of the process, but it can be also other evidences, like a picture of the signal well placed according to the requirements we have. So this is this process is is in work in progress, to be very honest with you. And what we would like is to avoid too much workload on the side of the technical experts. That's why we try to find automated way to check the files when it is against an IDS, against a gherkin requirement that is expressed through a gherkin shape or language. And this is what we are dealing with this time. Again, working on the process and then trying to apply it on the 3 business cases we have. So that's the end of the loop, and it leads us to the conclusion. The last slide is about the schedule of the project. I will just comment part of it. Just to let you know that we are where the deadline is placed in the schedule of the project. So we are at a turn in the project where we start to get results from the software vendor. We are streamlining, let's say, the validation process, and we'll implement it for the first time in a couple of weeks. We have this game this afternoon that will be also a real test for the output of provided by the software vendors. but it's not the end of the story, and I'll let you finish, Dieter.
Well, thank you, Etienne. What is left after the project? What are the traces of the project? Well, we are sure we will have in place an efficient methodology as we have planned. And we have this efficient methodology with a high level of confidence. And this confidence comes from 3 pillars, basically. It's robust. We can answer the same questions regardless of the conditions of use. It's replicable. As we said, there are plans to use other business cases, more business cases within the railway organizations. And it's scalable, which goes in the very same direction. And this brings us right to the very last slide of the presentation. We do this project under the supervision or in order of our stakeholders. So we deliver added value to our stakeholders. And this added value they request was formulated in the project goals. One of the project goals was that stakeholders wanted the usage of IFC 4.3 in contracts. Yes, we can do this. We have developed the capability to use this IFC data exchanges in procurement contracts. Another request was that we have the capability that we have a software that is capable to import and export data in IFC 4.3 format. Yes, we have a harmonized process to specify the technical requirements for the software implementation. And finally, we have processes and solutions that can be used by stakeholders. I think it's now clearly what also you said before, that the method will be there and ready to deploy. So it's up to the stakeholders then to implement this and use the message within their organizations. And it also helps with the validation done by the people, by the staff from the stakeholders, in order also to spread the knowledge within the stakeholder organizations. So these are the clear benefits for the stakeholders with this project. Thank you. And we are open for questions now.
Morning. From what I see, you have made more in electrical cables and so on, but for the track is the same, no? And also, you can also connect to the milestone the electrical cables and the track and everything that you can do.
Well, here the precise answer is we expect that we can do this, and we expect that we can show it once our business case 3 reaches the implementation stage with the software vendors. So we are working towards that. And what also should be stressed again is that the railway as such is a very complex system. I think all the railway engineers here can agree to this. Consisting of many different subdomains, depending how deep you go, might be 20 on the top level. I think we are 7, 6, 5, something like this. And a major challenge indeed is the federation of all this information to have at the end. And it has to be seen whether this will work with IFC 4.3 capable software already out of the box. We have to see this. But at the end, there will be one logical data set supporting all the infrastructure information needs for all the other rail systems. Operations, maintenance, planning, whatever. Yeah. That's the, I would say, is the main target. And supporting the expectations of the stakeholders as they have been presented at the end is just a first step going into this. It's my humble opinion.
Sorry, just to add, and in the future you plan to have IFC for all the objects for the railways, or because in the end we will have tracks, we will have cables and everything, but it's foreseen to have in the end all the objects with IFC code?
I think that's up to our stakeholders, who will be the users of this standard. But in my perception, I think that's the case. That's what they want to do. There are quite a big number of them here in the room, so if somebody has a different opinion, please speak out. But I think that's the ultimate goal, yeah.
Maybe one more answer to the question. I think in the IFC schema, we have already all the concept regarding the railway project. So we have already some concept for track, for signal, for supply, energy supply, etc. So the concept are already in IFC 4.3 schema, and we have also uploading in a BSDD the data dictionaries that can be used for properties that are not included in the IFC schema, but that are very useful for IFC for railway projects. So we have now in the schema many concepts to be used. Now what we want to do is to express them as requirements in contracts and as requirements that can be checked for the quality of the model. So and to play some usage of this schema, IFC schema.
I can try an answer. Again, what we tried to do in the frame of this project is to fine-tune and to streamline a methodology that will be a good candidate or the better vector to address what you just said, which is definitely a use case that we'll have in the 38 Düsseldorf process that I just mentioned before. It would be same for the gauge, dynamic gauge creation along the alignment. I'm sure that it is a key thing for most of us in this room. The fact that we are able to create the connection between the timetable, the data system, the signaling and everything linked to the IFC is definitely a target that we have. What we tried to do in this Imble experience with this project is to find the good way to make this link between the stakeholders that are very technical thing to say, the IFC schema that is how it is today, and find a way to talk with the software vendor to let them understand what are the needs we have. So very concretely, today we have only 3 use cases that are not the one that you mentioned. And what we believe hard is that the way we proceed could be used for addressing what you just described.
If I may make an additional comment here, and this comment is very speculative. Yeah? It's speculation about what will happen in the future. But as a matter of fact, there are many vocabularies out there in the rail domain working to support data exchange. And I think a major issue will be to select the proper vocabulary for a specific usage and then connect them together. Yeah? Here in Europe, we have a thing called ULinks, which is defining all the interfaces in the interlocking system, safety, security. I don't think it does make any sense to provide the ULinks functionality inside IFC. Don't think so. Speculation. But it would make much sense to connect them together at some point in time. And maybe that's now the time to welcome Pierre and Henri from OSC, who here as representatives of this larger approach here. IFC has a very specific purpose doing construction, design, and buildings. It's now extended to linear assets. And then we have these many layers of functions, systems. And for this functional views, system views, I think there are many vocabularies out there who can be used to address specifically that. And for the industry, for the infrastructure managers, for the rail operating companies, it will be crucial to interact those vocabularies for one common platform, track, line for communication. Speculation. It's difficult to talk about the future.
If I may, so yes, I'm Etienne from UIC, and just to echo the words of Andreas, so there are European programs on that topic as part of the Europe's Rail Joint Undertaking. They are looking essentially at studying things like traffic management, capacity management system for railways, and one of the key things to solve is how to get into those programs of simulation in certain cases or monitoring whatever, the representation of the railway networks that would be underlying. And there, from our perspective in UIC, so we've been collaborating with the IFC, and particularly in the IFC rail, to try and bridge the output of what IFC is doing with the rest of the modeling ecosystem. In particular, in the case of the signaling CCS, there is the ULinks and ULinks data prep that's working on this, but there's other vocabularies that are already being developed to try and make sure that ideally, if somebody has a representation of the railway system in IFC, potentially we can extract the right information to actually feed into another system. Because depending on the use case, sometimes you would need very accurate geometrical representation of the track, but sometimes you actually don't really care about the geometry, you just want the logical topology of the network. So ultimately, I think the main point is being able to bridge those different models and to make sure we don't duplicate too much the effort across the industry.
Thank you. Are there more questions? If not, thank you for your attention, for your attendance, and have a happy lunch and a great afternoon session. Thank you.